Hello everyone. Today we're going to look at a review of finding vertical asymptotes and wholes of rational functions. Now, as a reminder, a rational function is any function where you have what looks like a fraction. So it's one polynomial over another. Now, the difference between a vertical asymptote and a whole depends on the factors of the numerator and the denominator. When you factor out your rational function, because that's how we start, we would start off by factoring. If a factor from the numerator cancels out with a factor of the denominator, that means that we're going to have a whole where that x value is equal to 0, where that particular factor equals to 0 and we would solve for x, that would be the whole. Now we would have a vertical asymptote whenever the denominator equals to 0 and it is not a common factor of the numerator. So let's go ahead and work through this process. We have here a visual, first of all, so we can work this out algebraically and then confirm our results with the actual graph. So we have this function, f of x is equal to x squared minus x minus 2 over x squared plus x minus 6. So our first step is to simplify this rational function. So we're going to factor the numerator and the denominator. Now x squared minus x minus 2 can be factored to be x minus 2, x plus 1. Remember, when you are factoring, you are looking for the two numbers that would multiply to give you the last and add to give you the middle, and that would create our two factors. Since negative 2 times positive 1 is negative 2, and negative 2 plus 1 is negative 1. So now we're going to look at the denominator, x squared plus x minus 6. When we factor, we're looking for the two numbers that would multiply to give you negative 6 and add to give you 1. So our factors here would be x plus 3 and x minus 2. When we look at our rational function, we look for any common factors. We have the x minus 2 in both the numerator and the denominator, so they would cancel. So my simplified form of this rational function would be x plus 1 over x plus 3. Now to find the equations of the vertical asymptote and the location of the whole. The equation of the vertical asymptote would be x is equal to negative 3. Since remember, we find the vertical asymptote by taking whatever's in the denominator and making it equal to 0. So when we do that, we would subtract the 3, so x is equal to negative 3. And if we look here on the graph, this would be my vertical asymptote. Now it's important that I highlight here that what we are writing down is the equation. This is the equation. Why is it an equation? Because we have that equal sign. In calculus, we need to be very particular with our notation. You can't just say that the equation of the vertical asymptote is negative 3, because what's negative 3? X is negative 3, so that's why we write it out this way. Now we're going to write out the equation of the location of the whole. The whole is where you have those common factors. So the common factor here was the x minus 2. And we make that equal to 0. And now we solve for x, so I would add the 2 to both sides. And we get x is equal to 2. So this is the location of my whole, which as you can see on the graph is at x is equal to 2. So here we're using the graph to verify our results. Now we're going to practice finding vertical asymptotes and wholes without the graph and basically trusting our algebra here. So let's start with this function. Remember that our first step, if applicable, is always to factor. In the numerator, we have x squared plus 2, which cannot be factored. Because remember, if we ever have just two terms where it's x squared and then a constant, the only possible way that you can factor is if it was a difference of squares. But this is plus, so it's not a difference. So I can't factor this. So we're going to leave that. In the denominator, it's x minus 2, which also cannot be factored because it's linear. So this is the most simplified version of this rational function. Since nothing here would end up canceling, that means that I have no wholes, which is fine. You're not necessarily going to have a whole and a vertical asymptote each and every time. Now in the denominator, we have x minus 2. So to find the vertical asymptote, we set x minus 2 is equal to 0. To solve, we would add the 2, so we get x is equal to 2. So this is where I have the vertical asymptote. Let's look at this next one here. The numerator is just x, nothing to factor, and in the denominator is 1 plus x squared, which also cannot be factored. So we're going to leave it. We can't simplify this. Nothing here would end up canceling. So again, this means that we have no wholes. Now to figure out the vertical asymptote, we're going to take the denominator and make it equal to 0. We would first subtract the 1 on both sides, so we get x squared is equal to -1, and then we square root both sides. Now what happens here is we get x is equal to plus or minus the square root of -1. And if you remember, we cannot have a negative inside of a radical because there are no two identical numbers that would multiply to give you a negative. So that means that the denominator will never equal to 0. And if the denominator never equals to 0, that means that there are no vertical asymptotes either. Now this next one, we have x squared minus 3x plus 2 over x squared minus 1. Here we can factor everything, so let's go ahead and start off by simplifying this rational function. In the numerator, I'm looking for the two numbers that would multiply to give you positive 2, but add to give you -3, which would be -2 and -1. So my factors here are x minus 2, x minus 1. In the denominator, x squared minus 1, this is a difference of squares. First of all, it's a difference because of the subtraction. X squared is a perfect square, and 1 is a perfect square. So as a reminder of how to factor a difference of squares, we square root the first term, so x. We square root the second term, which the square root of 1 is 1. But remember, when we square root, it's always plus or minus, so we're going to make one factor positive and one factor negative. Now that we have this set up, we look for our common factors, which is the x minus 1, so this can cancel out. So my simplified rational function is going to be x minus 2 over x plus 1. Now, for the vertical asymptote, that's when you look at your rational function, the simplified version, we take the denominator, and we're going to make it equal to 0 and solve for x. For this, we would subtract the 1, so we get x is equal to -1. This is the vertical asymptote. Now for the whole. Since we do have a common factor, that means that we do have a whole. And the factor that canceled was the x minus 1. So we make that equal to 0 and solve for x. We would just add the 1 to both sides. So x is going to equal to 1. And this would be my whole. Last one here, we have f of x is equal to x squared plus 2x minus 35 over 2x squared plus 10x plus 8. So let's start with the numerator. The two numbers that would multiply to give me -35 but add to give me 2 are positive 7 and -5. So my factors would be x plus 7, x minus 5. Now in the denominator, 2x squared plus 10x plus 8, we can't just jump into this step and look at what two numbers multiply to give you 8 and add to give you 10, because we have this 2 in front of the x squared. So that means that we're going to have to factor out the 2 first and then continue to factor. So I'm going to take out a 2 from each term, meaning I'm dividing 2 from each term. So this would be x squared plus 5x plus 4. Now we can continue to factor that. So let's write this out here. the numerator x plus 7, x minus 5, and in the denominator we have that 2, and now I'm going to factor the rest of this quadratic. The two numbers that multiply to give you 4 and add to give you 5 would be 1 and 4. So my factors would be x plus 1, x plus 4. Now if you look at your factors, it looks like there are no common factors, because in the numerator we have plus 7 minus 5, in the denominator we have plus 1 plus 4. There's nothing in common in both the numerator and the denominator, so nothing is going to cancel. Again, since nothing cancels, this means that there are no wholes. Now let's work on the vertical asymptote. Just because in all of these other examples we've only had one vertical asymptote or none, it is possible to have multiple vertical asymptotes, which is the case here. So we take all of those individual factors, the x plus 1, we make it equal to 0, and the x plus 4, and make it equal to 0. For this first one, I would have to subtract the 1, so x is equal to negative 1. And for this second one here, I would have to subtract the 4, so x would equal to negative 4. This means that I have my vertical asymptotes at x equals negative 1 as well as negative 4. So this is the prerequisite skill that I wanted you guys to review before we get into finding limits. So I hope that you found this helpful, and that's it.